Welcome back. Today's session is about break-even point. Break-even point analysis will be covered in 3 sessions. In the first session, we will move very fast and then complete the whole topic, including break-even analysis, then margin of safety, marginal cost, marginal revenue, and finally cost indifference point. So, let us move forward. So, break-even point is a level of production and sale when the total revenue is equal to total costs. It is at that point where company barely meet all their expenses from sales. One thing we should always remember is that whatever expenses you incur, whatever payment you make, it has to come from sales. Sales is the only revenue sales is the only incoming revenue that is incoming cash flow that is coming, and we have to meet all the expenses. Whatever will be left is the profit. So, after break even point, if you can make more sales, only then you make profit. At below break even point, you actually incur loss. So, beyond break even point, whatever you sell is your margin of safety. We will discuss that moving forward. Now, cost is divided into 2 categories for conveniences: fixed cost and variable cost. This helps us to analyze profitability and decide at what level we are going to make profit, number one. Then it helps us to compare multiple business models, meaning which one is giving better profit, which one is giving profit at a lower capacity utilization, etc., etc. Fixed cost is a cost that does not vary with the level of production, meaning that it remains constant no matter whatever is the level of production. Even if you keep the plant shut for a while, keep the company closed for a while, you have to incur these expenses, like rent, for example. You have to pay rent as long as you occupy the place. Variable cost varies with level of production, meaning that if you produce 1 unit, you incur certain cost. If you produce 2 units, you incur exactly double that cost, multiplied by 2. If you produce 100 units, the same cost is multiplied by 100. So these kinds of costs are part of variable costs. Now, from here you can put them in numerical term in a formula. See, profit is equal to sales minus all the cost. Cost is divided into 2, fixed and variable. We also divide cost into direct and indirect. We'll discuss that later, but first thing is about break even, so we just stick to this. Just for the sake of formula, let us assume that selling price is denoted by S, quantity sold is Q, profit is P. Therefore, sales is equal to quantity multiplied by selling price is Q into S. Total variable cost is unit variable cost multiplied by quantity, that means Q into V. Total cost is variable cost plus fixed cost, that means Q into V is the variable cost plus F is the fixed cost. So, put them in the form of a formula. P means profit is equal to sales, total sales, that is Q into S, minus initially variable cost, that is quantity sold, into unit variable cost minus fixed cost. Fixed cost is annual cost. If your estimation horizon is a financial year, then fixed cost is a annual cost. If it is quarterly, then it is for quarter. So, you make little bit of transformation and you get Q is equal to F plus P divided by S minus V. Why this formula is like, if you have some profit in mind, meaning that if you have a targeted profit, then this is the quantity that you have to produce to make that profit. So, you can actually plan profit priorly by knowing the quantity, meaning if you have a targeted profit, then this is the quantity that is to be produced. So, putting this in the form of a kind of an infograph. So, on our left is that total circle is the sales, then the blue one is the fixed cost, the green one is the variable cost. Now, you remove one by one the fixed cost, and then the variable cost, whatever is remaining is the profit. Now, talked about fixed cost. Suppose you are starting a ready-made garment business. Now, you need a premises or a building where you will be putting all the sewing machines and people will be working inside, inventory will be maintained. So, the rent that you pay on an annual basis or monthly basis, you have to pay on a regular basis. Whether you produce 100 units or you produce 100 million units, you have to pay the rent, same rent. So, that is why it is fixed cost. Similarly, whatever you pay on a monthly basis, annual basis, without regard to the level of operation, those are part of fixed cost. Variable cost, it varies with level of production. As I said, if you produce 100 units, you incur some cost. If you produce 200 units, it will be double that. So, let us show it with an example. Material cost is variable cost. How so? Look at this. Suppose you are manufacturing shirt. So, for one shirt you need this amount of fabric. For one shirt you need this many buttons. You need this much of threads and other consumables. You need a labor to stitch that. So, for every shirt you may have an agreement that per shirt I am going to pay you this amount of money. So, for one shirt these are the expenses. Now, suppose you are producing 2 shirts, it will be double that. If you are producing 16 shirts, it will be 16 times that. So, this is to show that variable cost proportionately increases with level of production. So, this is how variable cost is kind of to be understood. Now, putting it again in the form of a formula, so far we have seen profit, but suppose you are thinking in terms of break even, and we have already defined that break even point is a point where profit is 0. So, in the previous formula you just put P is equal to 0 to get Q star. Q star is defined means the quantity that is to be produced and sold. Note this produced and sold construct, meaning whatever you produce you sell that. So, the quantity that you have to produce and sell, so as to come to a point where all the sales is equal to total expense. Total sales is equal to total expense. Beyond that, sales will be higher than total expense. Below that, sales will be lower than total expense. So, if selling price minus unit variable cost, okay, the denominator here has a meaning. It is defined as contribution margin. S is the selling price per unit, B is the variable cost per unit. So, per unit selling price minus per unit variable cost is equal to contribution margin. It has a lot of significance, we will see that moving forward. So, break even point can be defined as fixed cost divided by contribution margin. Total sales minus total variable cost is the total contribution, that means contribution. So, there are two different terminal, one is contribution margin, another is contribution. When you say contribution, it is the total sales minus total variable cost. When you say contribution margin, we say that it is units selling price minus unit variable cost. Here is a very simple example. Selling price is 100, variable cost per unit is 60, fixed cost is 2 lakh rupees. So, what is the break even point? It is just fixed cost divided by selling price minus variable cost is 5,000. So, 5,000 units are to be produced and sold so as to meet all the expenses out of sales proceeds. Showing it graphically. Suppose this is the very fixed cost. Fixed cost is fixed irrespective of the quantity. So, x axis is quantity, y axis is either cost or sales. So, across x axis fixed cost is same. So, that is why it is a horizontal line. Variable cost gradually increases proportional to the sales, it is just y is equal to mx. So, the slope of the variable cost curve is unit variable cost. So, it increases with unit variable cost, you just multiply with the number and you get that. So, you move the variable cost line slightly above and let it start from where fixed cost starts, that line represents the total cost line. So, forget about the previous lines, this is the total cost line. Now, this is sales. So, sales starts from 0, because if you sell only 1 unit, if you do not sell anything, so your sales is 0. So, as you go on, move on increasing your sales, the line keeps on increasing, and the slope is obviously, as you can very well guess, is unit selling price. So, if multiplied by the number of units that you sell, you get that point. So, x versus y. Now, where this sales line and total cost line is intersecting, that is the point where total sales is equal to total cost. So, that is defined as break even point. So, here as we have seen, 5,000 is the number of units to be sold, produced and sold to break even. So, this is demonstrated here, and you move away from that forward, you make more profit, and you go backward, you incur more and more loss. At point 0, you have no sales whatsoever, whereas you have the full fixed cost. So, loss is equal to fixed cost. Now, the second point that we wanted to discuss is margin of safety. Margin of safety, as we have defined, is the level of production which is away from the break even point, is the number or amount by which you plan or your planned production and sale is above the break even point. So, if your break even point is 5,000 and you are planning to produce say 6,000, 7,000, 8,000, 9,000, whatever. So, your planned sales minus break even point is the margin of safety. Why is it safety? Because if you are planning to sell much above the break even point, that shows that your operation is not so sensitive to the market, say market vagaries, meaning that if market situation deteriorates and your sales come down, still you are kind of comfortable till the point where your total sales is 5,000. It indicates number of the same thing, actually means how far you can decrease your sale because of market situation. Putting it differently, it signifies how sensitive is your present operation to the market fluctuation. Suppose the market condition goes bad and your sales goes down, but still if you are almost halfway through, still you are comfortable. Showing that graphically, this is variable cost and fixed cost, this is your total cost, sales, and this is break even point. Now, suppose you are planning to operate at a level of 9,000. Why 9,000? Suppose you think that as per present market condition or based on little bit of a market research data, you think that you can sell say 9,000 units. So, you plan to sell 9,000. So, this is your planned sale. Now, the difference between 9,000 and 5,000, the difference between these 2 points is nothing but margin of safety. Now, about all these estimation, actually there are many assumptions. Like at the beginning I said that there is no inventory built up, meaning whatever you produce you sell in entirety. Similarly, there are many, like cost can be divided into fixed and variable. In reality, you will find that there are some costs which have a component of variable as well as a component which is fixed. So, there are kind of mixed cost. So, we will talk about that later, but initially we presume that cost can be divided into fixed and variable. They change linearly, like as I said that both the line, the sales line or revenue line and total cost line is a straight line, meaning y is equal to mx. But in reality, if you produce more, you buy more, cost of production goes down because of economy of scale. But here we think everything is linear. We don't consider all those special cases. Volume is the only cost driver, meaning that for variable cost you just multiply unit variable cost with volume. So, volume is the only cost driver, volume is the only revenue driver. Then relevant range of volume is specified within which assumption hold, meaning if we presume that these are the total sales and total production. So, all our assumptions are valid within that relevant range. Inventory level is assumed to remain constant, meaning that whatever we produce, we sell that. If we cannot sell that, In reality, we actually can't, or maybe we sell even more because we inherit some stocks from previous year, and if the sales is going okay, then we sell even more. But then for this estimation, we presume that whatever we produce, we sell everything. Without that, actually it cannot be done, means it becomes very complex. So that is why these assumptions. Sales mix, suppose you produce 3 product or 4 product, and one product is at 10% of your sales, another product say 40% of your sales, something like, means there is this is called sales mix. This does not change. If that changes, then the structure changes, because one particular product may have certain kind of variable cost, certain ratio of variable to fixed, another may not have the same ratio. So it may change, but for calculation we presume that sales mix remain constant. So no inventory build up. Change in volume of sales does not affect the price. As I said, there is no economy of scale. There is, but we do not consider it here. Labor cost per unit remains constant. Either estimate the BEP for one product, or the sales mix does not change, as we discussed earlier. If you are producing multiple product and market situation is such that product mix is changing dynamically, then it is very difficult to estimate. So here is the same example extended for margin of safety. Suppose you plan to produce and sell 9,000 unit, 9,000 minus 5,000, 4,000 is the margin of safety. Showing it graphically again. So these are already discussed. Let us move fast. Now suppose this is more important about, this is application of break-even point analysis. We have seen where the break-even point lies, and we have seen that this helps us to plan profit, meaning that exactly at what point we are going to incur, we are going to make start making profit. That is fine. But there are other issues about other possibilities using break-even point, which are to be understood. They are more important than break-even point. Suppose you have two different for the same business model, you have two different ways of execution. Maybe one is labor intensive, the other is automation driven. So automation technology, means the technology with automation will come with a lot of capital investment, because machine is going to cost you money, whereas labor intensive, the initial cost will be less. So suppose we start explaining with variable cost first. Suppose in automation the variable cost will be slightly less, because you will be paying less labor cost, your wastage will be less, whereas for labor intensive one, the labor cost will be more, and maybe rent of course is a fixed cost. So let us not move, just let us see graphically how things changes, how the break-even point changes with change in say variable cost. If you remember variable cost, you can look at the graph, the orange color line, the bottom one is the variable cost, then you shift upward is the total cost. Now suppose you implement automation and your variable cost line slope reduces, meaning that per unit variable cost comes down. So the slope reduces. So the dotted line is the new variable cost. So the total cost is, so this is the new total cost. So the break-even point will be here. So you can see that if you have a structure where your total variable cost per unit comes down, then the break-even point will be lower. This is to demonstrate the same business this way. So this is your loss zone, this is your profit zone, and this is the break-even point. Now suppose if you are going for a automation, or say something where it is capital intensive, so your capital cost is more, so term loan interest will be more, your depreciation will be more, so fixed cost will be more. Let us move the fixed cost up. Fixed cost is fixed cost, that means it remains horizontal, but then line will be shifted upward. Suppose this is the line where the fixed cost, this is the variable cost, new variable cost, this is the new fixed cost, now this is the new total cost. So now let us see where does the break-even point moves. So break-even point is here, which is slightly higher than the previous one, but then it is lower than the original one where we started discussion. So here is a comparison. only change in variable cost. If you have capability to change your variable cost without affecting the fixed cost, that is the best option. Your break even point is much lower at about say 3,000 or so, not even 3,000, 2,000 something, and if that has to be achieved with little bit of more capital investment, then break even point will be shifted towards right, and then but still it is less. And then here is the structure of your profit loss account. Now, if the next topic actually is about degree of operating leverage. Before we go to the topic, just notice one thing. For low, when the variable cost is low, or maybe in the original case, if you see the total sales line and the total expenses line, you see the angle between them is small, whereas the angle between the new total cost and new sales is quite large. Remember this, that means here for every incremental unit the profit is higher. The angle between them actually, or the slope of the sales line minus the slope of the total cost line, is the profit. So, for lower variable cost and higher fixed cost, the gap actually, the angle actually is higher and you make more profit. So, let us define that part. This is the higher angle and the previous one is the lower angle. Operating leverage is defined as it is the firm whose operating income increases with respect to increase of sales. If the operating income increases at a very high rate, it is called very high degree of operating leverage. Lower the variable cost, higher the operating leverage, because low variable cost is high fixed cost usually, because you attain low variable cost by investing in machinery, automatic machinery, etc. So, you have high fixed cost structure, low variable cost structure, you have high operating leverage. For companies with high operating leverage, as we have just seen previously, your profit or operating profit for incremental sales increases faster compared to companies with low operating leverage. So, operating leverage actually refers to the percentage of fixed cost that a company has compared to variable cost, as I explained. Stated another way, operating leverage is the ratio of fixed cost to variable cost. Then there is financial leverage. We perhaps discussed during balance sheet discussion. Financial leverage is one of the financial leverage is debt equity ratio. It explains the level of debt a company has, or it explains the ratio of debt to equity in its assets. Suppose a company has assets worth 100 rupees and their debt is 50, meaning their own money is 50, that is equity, and they have borrowed 50, that is debt. So, 50 is to 50 is 1 is to 1. Now, suppose they borrowed 75 rupees and they brought in only 25 rupees. So, debt is to equity ratio will be 75 by 25, that means 3 is to 1. So, this will be referred as highly levered company, whereas earlier if it is 1 is to 1 or lower, it will be less levered, something like that. Combined express the total risk perception on the company. So, high operating leverage means the fixed cost of a company is high compared to variable cost. We will discuss this in the next session in detail. Now, if you compare this same example with two different cost structure, one has lower variable cost on the left side, the other has higher variable cost. Suppose you are manufacturing say e-vehicle or say e-bicycle, meaning electrical bicycle. Suppose each unit cost 15,000 rupees of variable cost, whereas the other one costs say 20,000 rupees. The left side one is automatic machine, you have assembly line. The right side one is you fabricate one by one manually. So, here you are on the automatic side you have 20 lakh rupees of investment in capital asset, whereas this side it is only 2 lakh. So, likewise you can compare these two and you will see that After break even, your profit increases, means marginal profit increases faster compared to the one with lower degree of operating leverage. We will discuss this in detail later, but for the time being we just move forward. Another point is cost indifference point, meaning there will be a point of sales, meaning volume of sales, where these two kinds of cost structure will not be relevant. It will be indifference of the cost structure. The one that we have seen here, that there is a higher capital cost structure, there is a lower capital cost structure. Higher capital cost structure, you have lower variable cost. In case of lower capital structure, you have higher variable cost. You can see here variable cost per unit is 15,000 on your left, whereas variable cost per unit is 20,000 on your right. So, normally this is the case usually. So, cost indifference point says there will be a point where the point of volume sales where profit in both the cases will be same. So, here is an example. The blue line is the high tech line, meaning high capital investment company or business model, whereas the orange line or perhaps the red color line is the labor intensive business model where you have low capital investment, but high variable cost. So, you can see at some point this is plotted profit in lakhs and number of items sold is plotted that way. So, at some point almost like break even point, it is not break even point because this side it is profit and this side is number of unit. So, at some point of time the profit is exactly the same for both models. So, this is known as cost indifference point. What is the utility of this? The utility is this: suppose you are deciding whether to adopt the automatic machine model or automation model or to go for labor intensive model. Now, it is not a straightforward decision. It is not your liking that you would like to go for high tech or low tech or something. It is a commercial decision and you have to take it based on estimation. So, you plot this two and then you make some kind of prediction about your sales. Suppose your sales projection is something like 30,000 units. In that case, obviously you have to go for automation, because if you go for labor intensive model, your profit is visibly low, very much low. Whereas, suppose your sales projection is something like say 5,000 units. For 5,000 units, if you go for labor intensive model, you make more profit. So, unless you have future prediction about higher and higher sales, you should not obviously go for automatic model. So, here is an example about this two comparative study, meaning the first alternative is variable cost per unit is 40, whereas in this side variable cost per unit is 60, total fixed cost is 50,000, 30,000, selling price per unit remains the same, because it is the same thing that you are selling. Contribution is nothing but selling price minus variable cost is 60, here also contribution is the same. And then if you put it, meaning just assume that at some quantity q, profit in both cases are the same, and you find that q is equal to 1000, meaning that at 1000 quantity your, whether you take this model or that model, your profit is the same. Now, suppose your sales prediction is about say 500 or say 700 units, obviously you should go for low technology or low capital cost model, and for anything above 1000 you should go for capital intensive or automatic model. I think that's enough for this session. We will continue in the next session about break even point, and we will discuss more about all these problems. Thank you.